All right, so we're still in activity 20, and I'm now going to work try these BC letter A. This one, it doesn't ask for the general solution like it did in try these A. So let's just take a look at it here. So the first thing we're going to do, let's write the problem down. It is nothing more, they ask you to do 8 cosine x plus square root of 3, and that has to equal 5 square root of 3. The big difference is, on try these A, ask for a general solution. This time they tell you they want your answer between 0 and 2 pi, and this is where you have to know how to read interval notation. They give you a domain of answers. They want you to say, hey, I want my answers in this set range. They're telling you they want the answers between 0 and 2 pi. That means no negative answers and nothing bigger than 2 pi. Because the general solution gives you all. They don't care about all. They only want some of them. And this one is pretty normal between 0 and 2 pi. Now you do need to pay attention. When they give you the domain, your restriction, your constraint here, from 0 to 2 pi, that means they want the answers done in radians. If they want it in degrees, they would say 0 degrees to 360 degrees. And notice here with the parenthesis around 2 pi, if I get an answer that's 2 pi, it actually needs to be 0 because 2 pi is actually not included. We're all the way up to 2 pi, but we do not include 2 pi. We include 0. Okay, first thing we need to do is we need to isolate my trig function cosine x. That's the very first thing I need to do. So we're going to do some pretty fundamental algebra here. We're going to have to subtract square root of 3 from both sides because it's plus square root of 3. That is going to give me 8 cosine x equals 5 square root of 3 minus the square root of 3. I subtract the square root of 3 on both sides. Square root of 3 minus the square root of 3 right here. That gives me actually 0 right here. Square root of 3 minus square root of 3 is 0. That's why I didn't write it right here. So when we simplify this down, this gives me 8 cosine x equals 4 square root of 3. The square root of 3's don't go away. It's just like when you're doing 5 pi minus pi or 5x minus x. That other part comes down with it, and you're doing the math with the numbers in front, which is just nothing more than 5 minus 1. Now we're almost there. Now we're multiplying cosine x by 8, so we need to divide both sides by 8. When we do that, the 8 and 8 here cancel. And this is going to reduce to pi over 2. So now I have cosine x equals square root of 3 over 2. Now it's a lot like the very first one we did in try these A. We have cosine x equals square root of 3 over 2. So we need to get x by itself. We're going to do arc cosine. So we're going to do x equals arc cosine of square root of 3 over 2. And now I have something I can actually solve. Well, arc cosine of square root of 3 over 2, you have to know where to look. And of course, you have to remember CAS, C-A-S, CAS, C-A-S-T, where sine and tangent are negative in quadrant 4. And this time it's cosine. Well, cosine is going to be in quadrant 1 and quadrant 2. Well, this right here is positive, so it must be in quadrant 1. So we're going to look in quadrant 1 on our unit circle. Cosine is the x value for the x value of square root of 3 over 2, which is nothing more than pi over 6. Now remember, they expressed the restriction in radians, so you want to keep everything in radians. Don't use degrees. Well, that's pi over 6. We now need to get my reference angle so we can solve this problem. What's nice, pi over 6 is in quadrant 1. So my reference angle phi is actually going to be pi over 6. This is my reference angle right here. Now we're ready to actually solve this equation. So here we go. We have my reference angle. My reference angle is pi over 6. And I know cosine. Cosine right here is positive. So I'm going to need to know which two quadrants is cosine positive in. Well, if you remember, cosine, we can do all students take calculus, and cosine is positive in quadrants 1 and quadrant 4. So that means I need to use those set of equations and look at quadrant 1 and quadrant 4 to actually know which equations I need. All right, so quadrant 1, it simply said it's your reference angle. So it's going to be pi over 6. No math required. Pi over 6, we already have one of our answers down. Quadrant 4, we have to do a little bit of math. That's going to give me 2 pi minus pi over 6. Put that over 1. Multiply your fractions. Multiply the bottoms. That's 6. Multiply up. 12 pi. Multiply up. Pi. Bring your operator over. This gives me 12 pi minus pi, which is just nothing more than 11 pi over 6. And if you look in quadrant 3, 11 pi over 6 is indeed the square root of 3 over 2, what we're ultimately looking for. Well, now I have two solutions. I have a solution here. I have a solution here, and I have a solution here. Those are the only two answers between 0 and 2 pi. Therefore, 3 dots, therefore, x equals pi over 6 and 11 pi over 6. Guys, you don't have to do these curly brackets. I'm just used to doing it. It just means a set of answers for x. You can just say x equals pi over 6, comma 11 pi over 6. You don't need to worry about the 3 dots, therefore. It's just second nature to me.